So next, I'm going to give a brief kind of 10-minute intro to Radiant, and then we are going to have Keely give a talk on IEEE GRSS. Okay, you might have heard about Radiant or not, but I'm going to give a kind of a 1-minute mission vision thing. What is Radiant about? So Radiant Earth Foundation is a nonprofit organization. We were established about 3 years ago, and the mission is really about empowering kind of users, organizations, companies with tools that can basically enable them to use machine learning and Earth observation to address global development challenges. We work across different verticals, but really the main ones that we are targeting now is around training data and models for agricultural and land cover applications. And the vision is really a more strengthened, empowered global development community. It's not just us, it's really thinking about the community perspective. And we do this with kind of 3 pillars in the company. So Radiant ML Hub is really the key, if I may call it, product out of Radiant. It's a community resource for geospatial and Earth observation training data. How can we better share them? How can we better access them through the data provider to the user? Hopefully by early next year we are going to enable hosting and sharing of models. So if I have a trained machine learning model and specific training data, how can we better expose that? And this is going down the direction of benchmarking that I'm going to talk about in the next slide. And also potentially hosting competitions and challenges around those training data to enable more users to access them. The other aspect of our work is community, and that's why we are here. Working with the commercial sector and government and nonprofit sectors to convene these forums to talk about the challenges and issues that we have and come up with solutions that is community-driven thing. One of those has been the success of STAC, the SpatioTemporal Asset Catalog that Chris will talk about it, about the standards that is, again, all of the community has contributed to that. We also run a technical fellowship. I'm going to talk about it at the last slide that I have. And also hosting regularly kind of working group discussions around some of the aspects of ML and Earth observation. And lastly, about education. So our marketing and communication teams work on different aspects of communicating and raising awareness around what is really the art of possible in this space, what are things that are happening, basically expanding the user base of these technologies. You're here about analysis-ready data. What we think about is analysis-ready training data. And that's really a key problem that is coming up more pronounced these days, because we have the imagery now, we have a good cloud services, we have a lot of models, but always when you want to build a model, where is my training data? And that has been a challenge. For where we want to go and how this will work in practice, I'm going to get a bit nerd here. It's really having a Python library that I can easily search for training data, and with one line at the bottom, I can load the data in my environment. That's it. From there, I can invest in modeling, improving accuracy, checking with validation data, and so on. But now, this 4 lines maybe takes a couple of months of work from the developer, because they need to do all the generating of the training data, cataloging them, putting them in the right format, and then bringing to their code. Just FYI, this is not on pip, so don't pip install ML Hub Earth yet. But it will be there hopefully later this year. This is all hosted on the cloud. It's all enabled by STAC, I will show later. But why we are doing this? So what's the philosophy behind it? What we are doing now, mostly in the community, is, okay, I'm group 1. I generate my own training data. I will do my own training. I will build my own model, and I will do my own prediction, right? Okay, that's a good success. The next group does the same thing with the training data too. There's no sharing of training data. It's not possible in many cases. It's sitting somewhere not necessarily accessible, or even discoverable in many cases, right? This is where we want to go. Have a benchmark training data, so all these different groups can use the same data. Then if I'm a user of that model output, I can easily benchmark them and compare them. That's the vision we have. This was very, very simple demonstration of where we want to go from here. But I think I see many of the heads nudging there that this is really what we know is a problem, but we need to address it as a community. It's not just one organization who can address it. And that's why this is just the architecture, what will happen on Radiant ML Hub. Basically, a bunch of STAC catalog data here, all of the STAC catalogs sitting on ML Hub. The data can be anywhere. That's the neat thing with the STAC. The data doesn't need to be one place, but we can easily discover them using the catalogs. There will be an API, which is the SAT API development by Matt Hansen sitting somewhere in the room, and guys at the development seat. And then authentication and ease of access to the data through an API and Python client. But really the architecture is, okay, I want to have analysis-ready training data. How can I get it? If you would like to know more about what we do exactly, I would love to chat with you. Just find me in the sessions, but I want to briefly touch about our technical fellowships program. So we work closely with partners in the community, and we run a fellowship program. Fellows usually work on an open source project, whether it's on standards, on tools, models, or training data. We have 4 active fellows now. Chris Holmes is here today. The other 3 are not. Seth is in Portland, Yang is in Australia, Brooke is somewhere in San Francisco, so they're all over the globe. But they work, as I mentioned, on standards like a STAC. Chris will talk about it, I don't want to get to that. On tools like the cog validator that we host, the tiles.rdnt.io, which is a tile server for cog files on the cloud. And also STAC browser. From the modeling perspective, Yang is working, for example, on crop type classification using Sentinel-1 and Sentinel-2. Brookie works on surface water detection. And all of these are kind of open source models that will be published later, with also the training data that both of them work on. So this is another aspect of Radiant, working closely with partners. So all of these 4 people are employees of somewhere, but they work with us part-time on an open source project. With that, join us. Follow us on Twitter. One thing I want to mention is this Slack channel, which is for the ML Hub community. So you would like to engage, you can join this Slack channel, bit.ly Radiant ML Hub Slack. So you can join the channel and have conversations. And I would like to give a shout out to the funders as a nonprofit organization that has been a very privilege for us. Omidyar Network, Bill and Melinda Gates Foundation, Schmidt Futures, and McGovern Foundation. All of them have supported us through the last 3 years, and we are very fortunate to have their support. With that, I would like to invite Keely from IEEE GRSS to give a talk about their activities. Thank you.
Thank you. Good afternoon, everybody. So nice to see the crowd growing here at ARD 2019. And I'm going to give just a really brief overview of the IEEE Geoscience and Remote Sensing Society. Can I get a show of hands? How many of you are aware of GRSS, know what we do? All right, good. So we have some familiarity out there. How many of you are members? Not as many as there should be. We'll try to change that by the end of the week. So GRSS is a scientific society. And what that means really is that we're a group of scientists, researchers, practitioners, engineers, and really just normal people, nerdy people, that come together with a common interest and set of goals. And that's to really bring technical excellence as well as professional development and education to our community. The Remote Sensing Society, Geoscience and Remote Sensing Society, is one of 46 IEEE societies, and being part of the society brings a number of benefits. We have publications, conferences, professional activities, information services, and technical activities, and I'll share just a few of those highlights with you. In our society, we have over 75 chapters globally. Some regions are more active than others, and there is a strong need for one in Northern California. We also have a number of highly technically relevant publications, including JSTARS, which is going to be open access very soon, and which we have a special issue call for as part of this event. But we also have the IEEE Geoscience and Remote Sensing magazine, which if you're looking for something that is still very technically on point, but has a lot more high color graphics and pretty pictures, strongly recommend. We support community developed tools. So this is information around creating standards, evaluating data sets, bringing open algorithms together, and really just finding a lot of these global data sets out there that can be difficult to get a hold of. Through the different technical committees in GRSS, we have a number of those available online. We also work with a lot of different organizations to provide opportunities for innovation. One of our most well-known events is our Data Fusion Contest. This is a long-standing tradition, and some of the most interesting and innovative science in this area has actually come out of these contests. If you look at some of the top cited papers within the IEEE literature, they tend to be results or things that have come from the data fusion contest. We've been expanding that in recent years to sponsoring more technical events within the community, things like Earth Vision 2019, the Deep Globe Challenge as part of CVPR in 2018, and the Analysis Ready Data Workshop this year. Each year we hold the International Geoscience and Remote Sensing Symposium, which is the premier technical remote sensing conference. And we just finished this up last week in Yokohama, Japan. So it was 1 week, 2,600 plus scientists, engineers, 230 peer-reviewed oral sessions. Our opening ceremony was attended by the Emperor and Empress of Japan, which was pretty cool, as well as some of the classic Japanese mascots. And we had a number of different events that weren't just from sort of the standard academic. We run a technology, industry, and education track, which helps diversify the community. We also have 2 distinguished lecturer programs that help us share expertise and knowledge worldwide. We have an academic program and an industry program. And through these programs, chapters around the world can actually invite experts from different fields to come and teach a half-day seminar or course, which really helps us build the community in these global chapters. We also develop courses in remote sensing education. This can be continuing education, webinars for people at the more professional status, where we all are, as well as some really cool kids-based remote sensing materials that are available in a number of languages and really teach a little bit more about how we observe Earth from space, how do we make measurements with remotely sensed platforms. Probably more than anything else, we facilitate and connect. We try to bring people together. 2 of our most active groups are our young professionals groups. So this is the group of people who are 15 years or less into their career, so you can still be pretty far into your career and be a young professional. We also have the Inspire, Develop, Empower, and Advance Committee, which I'm the current chair of, and this is our Diversity and Inclusion Committee. These 2 parts of the organization really work to do a lot of community building activities, networking, and helping bring different opportunities to people from all walks of life within GRSS. So I will wrap up with just a couple of points about what GRSS can do for you. It's a great way to continue supporting education, to help people maintain and stay on top of what the most technically relevant work is out there. It's also an opportunity to promote your capabilities and products. It's a chance to really get involved with the younger remote sensing community, with the people who are working their way through graduate school, who will be the people that you're trying to recruit in 3 to 5 years. And it really helps bring the research and academic industries closer together. So come join us, share, meet, collaborate, and learn. I will leave with two shout outs here. The first is for IGERS 2020, which will be in Hawaii this year on the Big Island. There will be a really great technical program. Definitely encourage you to consider submitting a proposal for a session or submitting a talk or poster for that. And then finally, from this particular workshop, we have a special call for papers for JSTARS. So October 1 submission opening, March 31st next year submission closing. Make sure you get your paper in. This is a really great way for us to actually highlight some of the work that's been showcased here at ARD 2019 and get it out there for a broader audience. And with that, thank you for your time.
All right, so last talk of the block, and then we're gonna get to work, which is exciting. Okay, so again, let me welcome you all. I just wanted to run through some of the themes of this particular workshop, and I think are some of the themes we have organized the talk into, and give a sense of what are the kind of problems we're trying to tackle here in this particular workshop. So generally what we want to do is there's a lot of ARD standards going around, and we want to exchange input and drive the cross awareness of the work that is going on right now in generating standards for ARD. We also want to create for all the participants here a mental survey of all the current trends and how the data is being formatted, how we're hosting benchmarking data sets, what are the concrete definitions of standards, and then we're discussing, and there is some standards going on, but there's always this conversation of, are they being adopted enough, right? So this is the structure of the event. We have 3 days of talks. We're doing a round of meet and greet right now. We're going to have a meet and greet little event of about an hour, 40 minutes right after this. Then we're going to have what we call the plenary talks as the first round of talks. And then we're going to invite the speakers to come to the front to do a short panel and Q&A session, all of them together, right? And then we're going to go get dinner. So what's going on tomorrow and the day after? We're going to have 2 different form factors for the talks. We're going to have in the morning traditional talks. They're going to be about 20 minutes each, so 15 minutes plus 5 minutes of Q&A. Ideally, we'll stop the speaker. We won't stop the speakers, but we'll take questions about the methodology after each of the talks. At the end of the morning, we're going to have a data community panel led by Erin, and she will share some details about how that's going to happen. Then in the afternoon, the format for the afternoons is different. We're going to have series of 3 talks where we're going to run through the talks with no questions, and then we're going to invite the speakers in sets of 3 to do a panel that will last for about half an hour. So these are if you look at it, this is like an hour and a half blocks, right? 3 talks of 20 minutes, and then we're going to take questions. We have microphones in the front, and this is where we get to heckle each other, right? And then at the end of the day, we're going to get a really exciting panel to round up the day about what is the meaning of having data that is ready for machine learning analysis, right? So we always talk about analysis-ready data, and some other people mean analytics-ready data. So one of the questions we need to start having as a team is, ready for what, right? And so the first panel is going to be about analysis-ready data for machine learning. We're going to repeat the same pattern on Wednesday, and we're going to cap the workshop with a panel on what is the meaning of analysis-ready data for forestry applications, like a global application that is multi-scale and very challenging on every level, right? So this is what we're going to cap the panel on. So we are going to hire moderators during dinner. We have a lot of exciting sessions that we thought about moderating ourselves as part of the organizers, but what we're going to do really is walk around and try to recruit moderators for the sets of 3 or 6 talks, and invite those of you who are interested and some of you who might be reluctant, great moderators, to participate and lead some of the discussions. And the role of the moderator is going to be to keep everybody on time, and as well as leading the discussion session afterwards. This is what we did last time. Hence the crowdsourcing thing. Okay, we have some labels right next to the talks. I just wanted to go through what are the meanings of the labels behind the talks, because I think they capture the themes in analysis-ready data as we're practicing it today. So there's a first label that we put on some of the talks, which is what we call harmonization. And what we wanted to capture there is all the activities and practitioner that is happening in terms of making different satellites look like each other, different platforms of the same satellite look like themselves. So anything that is calibration and validation and harmonization of remote sensing data. With remote sensing data, we're going to call that harmonization. And hopefully we're going to get a lot of really exciting updates on the algorithmic side. We have another label that is called fusion. And what is fusion? Fusion is remote sensing data fused with proximal sensing data, or drones, or aerial, or SAR, or anything that is not optical remote sensing, right? Anytime you start fusing data, vector data, to create a data set that now is more than the sum of the parts. This is where we step out of optical remote sensing. The next level is going to be machine learning. Is when we get data at different levels of processing, and we're going to try to do inference on them. And we're going to talk about the pipelines we're building, the results we're building, how we build training data sets, how we will validate, and so on and so on. So that's another label we have in there. And these are very loose definitions because, as you know, this is a very cross-functional field. All the topics touch all the topics. That's why it's so hard. There's another thing which is what we call software. Software is going to capture any specification work that is about API interfaces, pipelines, web services, anything that is related to reducing to practice analysis-ready data, how these workflows look in practice, and what are the challenges and some of the solutions. Now, the theme, what I wanted to move after this topic is to a couple of big themes that are lurking in the background and across all these talks. And one of them is the theme of product levels. We've always been talking about analysis-ready data. Analysis-ready data for some people mean Landsat, USGS level 2 ARD, and for some other people mean something else. So one of the things that is presenting itself as a challenge to all of us in the industry is that the product level metaphor, it doesn't capture readiness of the data, right? So converging to a unified, ontology of product levels in the industry, I believe is one of the first order of business. We need to have a piece of code that sits somewhere that defines what are the product labels as a programmer would have coded it. Not a piece of paper, not a document, something that is live, that people can do pull requests on to define what product levels are. And product levels to a practitioner look like this. This is an empty table that captures the complexity of analytics-ready data today. We have a lot of different payloads in space of different flavors that we need to mix with each other. They have different latencies. Data might be interoperable at the pixel level, but it might not show up in your platform at the same time. They have different levels of processing at the geometry and the radiometry level that can be employed alternatively at every level of traditional processing. And they have to be delivered different ways. You're not going to deliver a scene the same way you deliver a time series, the same way you deliver an information feed. So all of them will have a complex decision about how do you deliver this data. Do you deliver a pointer to the data? Do you deliver the rasters? Is it push, pull, or pull delivery? How do you do this? And then we have the traditional levels. We have the entire universe of where a lot of my team lives in, level 0 and level 1 data, the data that comes from a payload. Level 2 data, the data that you have projected and done some sort of retrieval to turn it into surface reflectance. Levels of data that are harmonized. We're going to hear about some of our harmonized products. We're going to hear from ISA about their fused and harmonized products as well. And then you have other levels of product that are the three-dimensional products, point clouds, things like chips of data that are already chipped to be compatible with machine learning pipelines. And it turns out that each of these levels could be ready for some kind of analysis. So the idea that only level 2 ARD is what constitutes analysis-ready data is a very limiting idea, because a lot of people do analysis on the geometry side. So they want to pick level 1A data with a rigorous geometry camera model. Some other people might want, harmonized data that is on physical units at the sensor, and so on and so on. So analysis-ready data means really standardized data. It's any data that you know what exactly was done to it, with all the metadata to undo what was done to it, is ready for analysis. But we tend to call analysis-ready data the cartography level 2 ARD ready data, which is data that is ready to be mosaiced maybe. But that's one of the applications. It might not be ready for time series analysis. So this is some of the conversations I want us to have in the next 3 days, is how does this get converted into a piece of live code that sits somewhere so we can all influence it in real time, so we can exchange data, build new businesses, sell data, buy data, build proper payloads, which is what we do in our team, and so on and so on. So these are some of the challenges. Yes? No. Well, I was hoping we were going to have it at the opening panel tonight. No. Here. So we have our opening panel here, and I was hoping I was going to moderate the panel, and I was hoping to pose that question to the speakers. So, but we should have it every single night over drinks, and also this is it's a blueprint that we should use to read through all the talks, I would suggest. That's my suggestion. Big theme this year, as given by the presentations, agricultural time series, right? It's always nice to have a vertical. It's not everybody's vertical, but it's what we will hear a lot about, right? People are trying to put together data in the cheapest amount possible from all the possible sources you can gather to infer things on agricultural land. So this is what we have. It's very exciting, not the only vertical, but one that is pretty overrepresented. Another topic that is very interesting and lurking on the back of our minds is how do we serve whatever this thing ends up being? There's a lot of standards floating around. There's a lot of ad hoc solutions being concocted. Let's talk about that. There's going to be a lot of interesting conversations about how do you serve this data in a way that matches different applications, like web-based applications, actual analytics, and so on. So these are just the themes we have, right? There's a lot of heterogeneous assets in space. I think we're going to have probably close to 300 Earth observation missions in 2019. There is very mature communities of practice. I would posit that the science of this has been figured out. It's all out there. There's communities of photographers, people who do radiometry, instrumentation, mapping. It's the solution of the problems end-to-end that is very challenging. But we have a generationally and culturally heterogeneous field. People have been gone to school at different points in time in their lives. They have learned different things. They have different skills. But these problems are dominated by cross-functional challenges. The products touch everybody. No single community can really close the loop. That's why I would posit we're kind of stuck on how to exploit 300 Earth observation payloads in space. There's a lot of off-the-shelf technology to really drive to the bottom and make all of this really cheap. And I would argue there is a lot of money around. This is not a capital poor situation right now. You could probably fly any mission you want, and you can buy the technology. This is unique. It's a unique situation, I would say, in space, in the space segment right now, at least. And we have a lot of long-tail problems that drive complex requirements. So a lot of things end up being over-engineered or under-engineered because there's a couple of applications followed by 5,000 other applications that don't have clear requirements, and that hurts the entire stack. We have uncertain business models. We just don't know how to make money out of different parts of the stack. And we're only emerging to have standards that are actually adopted. And hopefully we'll discuss some of that. So, welcome to the workshop. Let's talk a little bit about what's going to happen in the meet and greet. The meet and greet is right after this. We're going to have you guys count from 1 to 10. And then we're going to do what we did last year, which is we're going to spread through the campus outside in the rooms and outside on the benches and in the rooms. We're going to have you introduced to each other, and we're going to have to pick 2 taglines of 2 challenges for analysis-ready data. And then we're going to have you pick a speaker, and we're going to reconvene in this room at 2:40, and we're going to go around the room and capture that, and have you guys to say a couple of words for a couple of minutes about what it is that that group, as you guys met with each other, ideally not people from your organizations, what new did you discover? What are the taglines? What are the things we want to talk about? I'm putting this slide here because we're a sponsor after all. So Planet is organizing its own users conference later this year, which is going to be really exciting. So if you want follow-on conversations that are about Planet products and uses specifically, right? Feel free to keep track of something called Explore 19. There's going to be a very exciting conference that our company will be hosting that is about actually Planet products and users and customers, which is not this event, but I wanted to be clear that we do have an event coming that is very exciting if you're a customer, if you want to be a customer. And yeah, so we have that. And that's a picture that we just took with one of our new payloads. And I would say thank you for your time.